To start with? You want to start with the top?
Yeah. We haven't really gone over these in class, but she said I should go over these with you.
Okay. So, when you are adding two fractions that have the same denominator, what do you do to the numerators?
Uh, you just combine them.
Yes. So what is this equal to?
So 2x.
X plus 2.
X plus 2, right?
In other words, you're doing this. You're doing x plus 2. And the denominator is what?
It's just the first denominator plus the second denominator.
No, it's the same. It does not change. In other words,
Oh, okay.
you have two fractions that have the same denominator. You operate on the numerator only, and you leave the denominator whatever it was. Now, what can I do? I have something interesting here. I have a term in the numerator that's the same as the term in the denominator. So,
You can't.
yeah, I can cancel that out, leaving 1 over x plus 3. So that's the answer.
Okay.
So you always want to simplify.
Yeah.
Okay, how about number 2?
Okay. Since the denominator is the same again, it's x plus 4 over x squared plus 6x plus 8.
Yeah, but the thing is that that denominator looks like it can be factored.
Yeah.
In the first case, it came to us factored, so we didn't have to do anything.
Yeah.
But in this problem, we want to make sure that we factor it if we can, because if we can come up with an x plus 4 as one of the factors, it's going to cancel out with that numerator, and it will allow us to simplify it. So,
Mm-hmm.
factor that denominator. What are both
So
signs?
then it's 4 and 2. It's addition, and then so then it's 4 and 2, and then yeah.
So the answer is 1 over x plus 2. All right, number 3.
So then that's b squared minus 9
And
over.
instead of writing it, let's factor it.
Okay. So then both sign it has to be negative, so it's plus and minus, and then it's 2 and 1.
Hold on. Those two numbers have to multiply to 3.
Oh,
So it's not 2 and
so
1.
then
It's got to be 3.
3 and 1. Yeah, it's 3 and 1, and then
That's the only factors of 3. Now, where does the 3 go? With the plus sign or the minus sign?
with the plus,
Go.
or no, with the
No, you're
yeah,
correct. The larger of the factors goes with the sign of the middle term. Well, the sign of the middle term is plus. So
yeah.
the 3 goes with the plus, the 1 goes with the minus. Now, we're not quite done because we can factor that. Factor that.
So it's the difference of two squares. So then it's b plus 3 times b minus 3
Good. And
over.
all over b plus 3 times b minus 1. B minus 3's cancel. What's my final answer?
B plus 3 over B minus 1.
Okay, good. That cannot be simplified any further.
Yeah.
Okay, let's do number 4. And this time, well, we'll do it in 2 steps. What's the first step? What's the numerator?
2a plus 2.
And then instead of writing out the denominator, factor it.
Okay. And then it's plus for both of them. And then, so then factors of 1. So it's just 1 and 1?
Yeah, when you see a 1, there's only one factor of 1. 1 times 1. Now,
Yeah.
is that correct? Does that produce 2a in the middle?
Yeah.
Okay. Now, can I factor the numerator? These problems, every problem on this page is a factoring problem. So when you see problems like this, you want to always be thinking factoring. Can I factor the numerator?
No.
How about a greatest common factor?
Oh, you can factor out a 2.
Leaving behind?
2 times a plus 1.
Ah, that's big because I got an a plus 1 in the denominator. So anytime I can produce a similar term, that's going to allow me to simplify it, which gives me 2 over a plus 1. That's my final answer.
Yeah.
And all of these problems look, in other words, that we were able to cancel, we were able to cancel that, we were able to cancel one of those, one of those. So far, all 4 problems, we've been able to cancel something from the numerator to the denominator. So you always want to factor. How about this one, number 5? What's the denominator going to be?
X plus 2.
What's the numerator going to be?
Would it just be x plus 10 and then plus x minus 6?
Okay, what does that give you?
2x plus 4.
That looks factorable.
Yeah. So then it's 2 times in parentheses x plus 2 over x plus 2, and that cancels, and it's just 2.
There you go. So all of these are pretty much the same. What's the denominator here?
A plus b.
What's the numerator?
3a plus 3b.
Is that the final answer?
No, you factor out the 3, so it's 3 times a plus b over a plus b, and then that cancels, and it's just 3.
Uh-huh.
Right.
Oh, I love these sessions where you do all the talking.
Yeah.
Number 7. Give me numerator and denominator.
X minus 9.
Good. No, it's not good. Here's what the numerator is. Let's over here on the right. We got 3x minus 4 minus, and you have to do the entire thing in parentheses, the entire other numerator.
So
Now remove the parentheses, and you still have minus 2x, but you end up with plus 5.
Yeah.
Now that reduces to x plus 1. So that's the numerator. The key with these problems is putting parentheses around that. If you do not put parentheses around it, you're going to get it wrong. Whenever there is subtraction going on, and I mean this subtraction, not this one to the right, you must put what is being subtracted in parentheses, because this negative sign applies to both that term and that term. Okay, factor the bottom.
So then it's 3 times x plus 1.
So you get 1/3.
Yeah.
That's the answer. Number 8. Factor.
So it's okay.
So
the numerator.
Let's skip a step.
Yeah. So then the numerator is 3 times x minus 3.
Good. Factor the bottom also.
Over 4 times x minus 3. So then that cancels.
All of these problems, these factors are the same. So if you come up with something like that, you've probably made a mistake. In other words, if you do not come up with a factor that can be canceled, so far, everyone we've looked at has a linear factor that can be canceled. So if you're looking at a bunch of problems that all have linear factors that can be canceled and you don't come up with one, you've probably made a mistake, and that's your clue. So the answer is 3/4. Now, maybe we'll get to problems where that's not true, but okay. Tell me what I should write for the numerator.
5a plus 1.
Good.
Over.
Factor it.
Oh. So then it's a times 5 plus 1.
5a plus 1.
Or yeah, 5a plus 1.
No, that you're going to try to duplicate whatever that factor is in the numerator. We're probably going to find something like it in the denominator. And
so then it
has to be exactly like it. So it's 1 over a.
Yeah.
Okay. Just before we go on to 10, tell me what this is.
1.
It's minus 1.
Oh yeah, minus 1.
If it was 3x over 3, excuse me, if it was 3 minus x over 3 minus x, that would be plus 1. But the difference between a minus b and b minus a is always negative 1. And you can see why. X minus 3 has to be equal to negative 1 times 3 minus x. Distribute the negative 1 and you get minus 3 plus x. That's the same as x minus 3. So that is equal to that, and that is equal to that. So whenever you have two terms that are subtracting and they're switched, always remember that's minus 1. Now, we may not see anything that difficult in these problems, but I wanted to point it out before we did. That's probably the hardest thing to see. Everything else, you're going to be canceling exactly like terms. This is the only time you're going to cancel two terms that are not the same. They're the reverse of one another, and they are subtraction only. In other words, x plus 3 over x minus 3, I can't do anything with that. That's not simplifiable. So you have to have x minus 3 over 3 minus x. Or really, I mean, a minus b over b minus a is always negative 1. Just remember that for the harder problems. So far, I haven't seen anything that hard. Okay, 10 gets a little harder. Factor the numerator of the top left.
Okay, so then I'm trying to write this out. Okay. So it's x and x.
Wow. Doesn't factor. Why would they give you one that did not factor? Nor does the next one. Okay, I see what they're doing. I see what they're doing. This problem is not factoring problem. What's the denominator going to be?
10.
Now, operate on the numerator. Tell me what you get.
Okay. Okay, so the denominator is 10 and then the numerator.
Notice that did not factor. I was going to factor it because it was a quadratic, but then I realized it doesn't factor. I'd have to use the quadratic formula, and I know that's not what they're looking for. They're not looking for you to apply the quadratic formula. But if we operate on the numerator, what do we get?
5x minus 5.
Minus 15.
Or, oh yeah, minus 15.
In other words, it's minus 5 minus 10. That's minus 15. Now, factor the numerator.
So then it's 5 times x minus 3. Over 10.
Now simplify that.
So then it's 1 times x minus 3 over 2?
Perfect. That's the answer.
Right.
Number 11. Let's just go ahead and operate on the numerator.
So it's 6 plus 2x.
Now factor that.
So it's 2 times.
Okay.
2 times 3 plus x.
Okay.
Over x times x plus 3.
Now what can I do with that?
You can cancel. Yeah, you can cancel the
3 plus x is the same. Yeah, 3 plus x is exactly the same as x plus 3.
And it's just 2 over x.
Cross those out. What I'm really doing is leaving a 1 behind. I'm not leaving a 0 behind. I'm leaving a 1. And it's important to understand that. So the final answer is just 2 over x.
Yeah.
Okay, let me scroll up here. So I have a little bit of writing room. Number 12. This is the first one we've seen that does not have the same denominators. So what is the common denominator?
The x minus 7.
No. You need a denominator that is divisible. In other words, that needs to divide evenly into whatever common denominator you come up with. If it was x minus 7, then 4 times x minus 7 would not divide evenly into it. So it's got to be the bigger of the two. So
then it's the 4 times.
That's the common denominator. Is 4 times x minus 7. And I leave it unmultiplied for a reason. Now, what goes right there?
The 5.
No, 5 over that is not the same as 5 over that. In other words, you have to put something in that circle that makes it equal to that. You can't change that fraction. You can change the denominator, but you got to change the numerator also.
Yeah, so then it's 20.
Yeah. Now notice that 20 over that is exactly the same as that. And that's the whole point. And over here, I didn't change anything, so it's just 3. So now operate.
So then it's 23 over 4 times x minus 7.
And that's the best way to leave your answer. You don't need to multiply the 4 times the x minus 7. Leaving the answer in factored form is actually superior to leaving it in multiplied out. Because I don't know what I need to do. I may need to multiply that answer by x minus 7. And then I'm much better off if I've left the denominator in factored form. And I cannot reduce 23 over 4. So that's as simple as I can get it. So let's look at 13. Common denominator
is the x squared.
Good. Top left numerator.
25.
No, it's got to be the same. That has an x squared on it.
Oh, top left. Yeah. So then it's just the same.
How about top right?
Then that's 25.
No? Remember, whatever you put there has to equal that. So what do I need to put there to equal that? Okay, here's how you figure it out. Here's how you solve it. You take this denominator, you divide it into the common denominator. What do you get?
X.
Okay, and then you multiply that answer by the numerator. So that should be 5x. Now, compare that to this. They've got to be the same, are they?
Yeah.
Yes, they are. Now, simplify it. Our denominator, we're going to start out with x squared for sure. What's the top become?
6.
That's the answer. $14. What is the least common denominator? And whenever I'm having to come up with a least common denominator, I always do it like this. In other words, I draw 2 fraction lines, and I know I'm going to have a denominator that's not the same in both cases. What's the denominator going to be?
What do you just square the bottom left denominator?
It's not squared. It's factor x squared minus 16, first of all. Difference of perfect squares again.
And it's x plus 4 times x minus 4.
Okay, so that's your common denominator. And it's the same thing over here. So what has to go in the numerator top left?
2 times x minus 4.
Notice the advantage of not multiplying those two together. If I leave it like I've written it, then it's really easy to see that that fraction is the same as that fraction, because I can see the x minus 4's cancel. So I'm left with 2 over x plus 4, which is what I started with. So whenever you're doing these kind of problems, do not multiply that bottom together. It makes it harder. Now, the only thing I have to do is make sure I add parentheses to that because I am subtracting. Okay, so our common denominator is this. Operate on the numerator. Do that.
So then it's, so then it's 2 times.
So this becomes what? 2x minus 8.
Yeah.
In other words, you do need to do that step.
Okay, yeah. So, okay. So 2x minus 8 and then minus. So then it's x plus or minus 4.
Now what can I do?
You can cancel x minus 4, so then it's just 1 over x plus 4.
Perfect. You seem to know this stuff, Blake. Pretty good.
Yeah. I'm catching on.
Yeah. Okay. When I see a problem that it's not obvious what the common denominator is, then let's factor to begin with. What's the left factor?
It's a times a plus 6.
How about the lower right denominator?
Then it's 3 times a plus 6.
Okay. That's my, no, it's not my common denominator. What's my common denominator going to be?
Just
You have to come up with something that is divisible by both of these denominators.
a plus 6.
That's not divisible by the right one or the left one. When I say divisible, I mean, is a plus 6 divisible by a times a plus 6? No. Those will cancel, but that's in the denominator. In other words, when I mean divisible, I mean evenly divisible. So you got to come up with something in the numerator, not the denominator. So what entity is going to be divisible by both that and that?
If you, like,
How about this?
oh, then you put both of the coefficients next to it.
Well, this thing that I just wrote is divisible by that. If I divide it by that, I get 3. That's a whole number. That means it's divisible by it. And if I divide it by this over here, I get a. That's a whole number in the numerator. So that's divisible by it. So that's definitely my common denominator, my least common denominator. Now, what goes right here? I'm doing this problem over here.
If you, so then you multiply that by 3.
Here's what you do. You can either kind of intuitively figure it out. In other words, kind of guess at something that whatever you get has to be equal to that fraction right there. Or you can do it in a more methodical way, which is divide that term into the common denominator, take your answer and multiply it by 10a. When you divide a squared plus 6a into 3a times a plus 6, you get 3.
Yeah.
Divided by a times a plus 6,
And you
get
3.
Now you have to multiply the 3 times the 10a, so you get 30a. And now check to make sure that is the same fraction as that. Is it exactly the same?
Mm-hmm.
Yeah. The 30 divided by the 3 becomes 10. And then I have 10a over a squared plus 6a. So I've done it correctly. And that's always what you want to check for. You just want to check to make sure that you've got it right. In other words, you always want to make sure that those two are the same. Okay? Now how about the right side? What goes here?
3a.
It's not going to be 3. The 3's would cancel and I would be left with a 1. So it's got to be 9 something.
Oh. Yeah, so then it's 9a?
Well, let's see. If it's 9a, then the a's cancel. The 9 over 3 becomes 3. And I end up with 3 over a plus 6. Well, that's not right.
Oh.
So let's go back and do it the official way. Let's divide our common denominator, 3a times a plus 6. Let's divide it by our denominator, 3a plus 18, which is 3 times a plus 6. A plus 6 is canceled, the 3's cancel, and I get a. So this must be a times the numerator, 3a. Now, is that fraction exactly the same as that fraction?
Yeah.
It is. It doesn't look the same, but it is. The a's cancel, the 3's cancel, and I'm left with 1 over a plus 6, but that's really what that is 1 over a plus 6.
Mm-hmm.
So I've got everything I need. Let me erase some of this stuff. Okay, I have a common denominator. I'm ready to operate on the numerator.
So then you get 27
27
over,
what? Hold on, 27 what? What's 30a minus 3a?
27a.
Over the common denominator. Always left unfactored. You don't want to factor that. Notice that if I'm sorry, you don't want to multiply it together. You want to leave it factored. Because when it's factored, I can do stuff like cancel. So what's the final answer?
9 over a plus 6.
Good, very good. And that cannot be simplified. I cannot divide top and bottom by 3. That was 15, okay, 16. Let's rewrite 16 and factor everything.
Okay.
Factor the lower left.
So then it's 2x so it's 2x times x minus 4.
Yeah, you can kind of get a clue from that.
Yeah.
Not always, but with all of these problems, they're giving you common factors. Okay. Now, if I add that fraction, now tell me what the common denominator is.
So then you have to multiply the right side by 2x.
Just tell me first of all, you got to figure out the common denominator. You can't really do anything else until you do that. What is the least common denominator?
X plus 4.
X
the 2x times x
no, it's
minus 4. Yeah.
It's the bigger
the 2x
things. It's always the bigger of the things. Remember that both these things have to divide into this evenly. Well, that divides into it evenly one time. And this divides evenly into it 2x times. So that works as a common denominator. And all I have to do is make sure that I can divide both denominators into it evenly. Now, what goes in the top left?
3x.
Goes in the top right.
4x.
4x squared. No, 4x. You're absolutely right. My mistake. In other words, my goal is to make sure after I've done it that that's the same as that. Always. Always do that step. And you'll see that it is. In other words, my x's cancel, my 4 over 2 becomes a 2, and those two are the same things. Now, keep going.
So then it's
become?
second x over 2x times x minus 4.
And again, you're going to see the advantages of not multiplying that out. What can I cancel?
The x's by the 7 and the 2.
You can't do anything with the 7 and the 2. So you end up with 7 over 2 times x minus 4. There's your answer. In other words, these x's canceled.
Yeah.
That's the only thing that can cancel.
Yeah.
Okay. All right, 17. 17, only way we're going to figure out how to do 17 is that does factor and so does that. In other words, if it factors, then you probably have to factor it. So what do I have in the bottom? In other words, let's start by just rewriting the entire problem, only factor each denominator. What does that become?
X and x. And then it's plus and minus. And then it's 3 and 1, and then 3 goes next to negative, and then 1 goes next to positive.
Okay, so that's that term there. Now factor the term, where'd that 6 come from? Oh.
And then
factor the right.
And then it's minus and minus. And then 4 and 3, and then 4 goes next, and yeah.
Yeah, if it's minus minus, then you don't have to figure out which side the 4 goes on. So when minus minus or plus plus, it's only a 3-step problem. Now, tell me what the least common denominator is.
So x minus 4 times x minus 3.
Well, it's definitely x minus 4 times x minus 3, but I think I also have to have an x plus 1. In other words, remember what we're looking for. We're looking for something that is divisible by that and that. And normally you can get that by just multiplying everything together. But because I have an x minus 3 and another x minus 3, I don't need to multiply those two together. But I do need to multiply the x minus 4 times the x plus 1 and x minus 3. Notice that this is the smallest term that is divisible by that and that. Okay? So let me put that in both denominators. It's definitely getting a little harder.
Mm-hmm.
Now, what goes here? And started out as a, in other words, make it 5x plus 9 times something. What must the something be? It's actually easier to just kind of do this intuitively.
X plus 1.
No, it's got to be x minus 4. Remember, that fraction has to be the same as this fraction. And the only way you do it is if you write x minus 4, because that cancels with that x minus 4, and then I got exactly what I started with. And also, if I want to look at it the other way, if I take this denominator and divide it into my common denominator, I get x minus 4, which I have to then multiply by 5x plus 9. Okay? Now, over on the right side, this is 6 times what?
X minus 1.
X plus 1.
Or yeah, x plus 1.
Yeah, because now you can see readily that the x plus 1s cancel, and I'm left with what I started with. It's always the key, is to make sure you end up with a fraction that has not changed. Whenever you're adding or subtracting fractions and you're trying to figure out common denominators. Now, we got a lot to do with the top. First thing we're going to have to do is distribute these. So multiply these two binomials together.
So then it's
Because
5.
we're adding, I can't do anything further until I combine the numerators.
Yeah.
So what's that new?
5x squared plus or minus 20x and then plus 9x.
This is minus 11x. I'll go ahead and combine those two. Okay, keep going.
Yeah, and then minus 28.
36.
Or 36. Yeah, 36.
And now because that's a plus, you don't really need these parentheses. Just go ahead and distribute the 6, and I'm going to write each term. Distribute the 6.
Oh, 6x plus 6.
Okay. That's my new numerator. Now combine that.
So then it's 5x squared minus 5x minus 36 over.
Hold on, we got a minus 36 and a plus 6. Minus 30.
Oh, minus 30, yeah.
Okay, let's factor that while we're there.
All right, so then it's, okay.
You can definitely take out a 5. Let's take out a 5 and see what we got.
Oh, okay. 5 times x squared minus x minus 6.
Okay, and I notice that I can factor that also. So let me make some room here. Over on the left side of this page. Always run out of room. Guess I need to learn how to write smaller. Okay, so factor that. So here's my new net numerator.
Okay. X, and then X, and then plus and minus. And then 2 and 3, and then 3 goes with the negative.
Okay, now let's put our common denominator under it and see what we can cancel.
Over X minus 4.
Okay. So this is our answer except for what we can cancel. What can we cancel?
The X minus 3s.
That's it. So our final answer,
5 times X plus 2 over X minus 4 times X plus 1.
yeah. We're going to write it exactly like that. We are not going to distribute. There's no need to distribute now because there's no advantage to distribute. In other words, you only distribute if you can simplify it further. And that's as simplified as I'm getting. I can't do anything with x plus 2, x minus 4, x plus 1, or the 5. So that's my answer. Let's see, where was that? That was 17. Okay. 18. Let's write 18 out, but before I rewrite it, factor that and factor that. And I'm going to start up here in the upper left. So I got x plus 4 over what?
X, and then it's plus and minus. And then factors of 28 to subtract a 3 is 9 and no, and then it's so 2 and 14 and then 4 and
let me help you. We're factoring 28, right?
4, 7 and 4.
Okay.
7 goes with the negative.
Let's just talk about this for a moment. You're pretty good at this, but let me just talk about how you find factors of 28. First of all, I see if I can cut 28 in half. And I can, which means I got to double that. Now, can I cut it in half again? Yes. And I got to double that.
Yeah.
And I just found my two factors that subtract to the number 3. Now, where does the 7 go? With which sign?
The middle sign, so the negative.
Okay. All right. Now the right side. Top's already factored. Put parentheses around it because I see that subtraction sign there, so I'm going to need parentheses around that. And in fact, lower right.
X and X, and then factors of 35 subtracted 2 is okay. So then you can't cut it in half. You can't cut it in thirds.
Hold on, you're perfect. I like what you're doing. Just keep going. You can't cut it in half. You can't cut it in thirds. If you can't cut it in half, you can't cut it in fourths. So there's no need to even think about fourths. But how about fifths? Can I cut it in fifths?
Yeah, it's 5 and 7, and the 7 goes with the plus sign.
Okay.
All right.
So now, what's a common denominator?
x plus 7 times x minus 5 times x plus 4.
Good. Write that in both places. That's my first step, and now it's going to be really easy to figure out what the numerator needs to be. What's the upper left numerator have to be? Let's start with what's there. And I know I got to multiply it by something.
Okay, so the upper left numerator has to be x plus 4 times 7, or x plus 7 times the x plus minus 5.
Now, here's what you need to do is which one is missing? The x minus 5 is missing, right? So I put an x minus 5 there. And now the x minus 5s will cancel, and that fraction is exactly the same as that fraction. So how about the right side? Go ahead and put x minus 5, knowing it's got to be multiplied by something. What is it multiplied by?
X plus 4.
Good. Because now that fraction is exactly the same as that fraction. You always want to do that check. Because in math, if you make mistakes, you want to find it out along the way. You don't want to do a 9-step problem, get to the 9th step, look at the answer and see that you don't have the right answer and figure out where you went wrong. You got to go all the way back to the beginning and do it all the way again. But if you're constantly checking at every single step, then you don't make those mistakes that you would have made. So it's really, really worth checking. Okay, now I've got a common denominator, but what do I have to do to these numerators?
Subtract them.
Well, normally you would have to subtract them.
Oh, but they're the same.
They are the same. So what's the numerator going to be?
Just x plus 4 times x minus 5.
Nope.
Oh.
I have a times b minus a times b. What have I got?
1.
0.
Oh, 0.
Yeah. And I could get it by multiplying these things out. Let me just do that. I got x squared minus x minus 20. That's what that top left one becomes. Minus x squared minus x minus 20. Well, those two quadratics are the same. If I have a quadratic minus exactly the same quadratic, it's 0. So I don't even care what the denominator is. The whole thing is 0. If your numerator is 0, the whole thing is 0. It's not 0 divided by this common denominator. It's 0.
Yeah.
In other words, if I said, what's 0 divided by x squared, the answer is 0. It's not 0 divided by x squared. It's 0. So the moment you discover your numerator is 0, you're done. That's the answer. And let's not worry about what happens when you have 0 over 0. That's a very special case that you won't really deal with until you start taking calculus. And they're not going to give you any problems like that, where you'd end up with 0 over 0. That's actually called indeterminate. But with any other case, if 0 is in the numerator, the answer is 0. If you end up with 0 in the numerator and the denominator, you don't actually know what that is. why it's called indeterminate.
Mm-hmm.
But if you have 0 over anything else, then the answer is 0. Now, I didn't actually have to multiply those two together to figure that out. I could see that I had an A times a B, and over here I got a B times an A. AB minus B times A is 0, always.
Mm-hmm.
All right. That was
18.
So 19. Let's rewrite 19, factoring everything. I think you kind of get the idea that no matter what you start with, the idea is to factor everything and then go from there. So, top left can't factor. How about the bottom left?
Oh, difference of two squared. Oh, okay. So then it's x plus 4 times x minus 4.
Okay. We're subtracting. The top right can't factor, but does need parentheses around it because of that negative sign. Factor the bottom.
X and x, and then it's plus and plus, and then it's 4 and 4.
Now, what is the least common denominator?
X plus 4 times x plus 4 times x minus 4.
Actually, yes, you're right. That's the only thing that divides evenly into and that divides evenly into. So that's definitely my common denominator. Let me put it in both denominators. What goes in the top left? We'll start with what's there. It's going to be multiplied by something. What is it?
The x plus 4.
And in the top right,
Then
3x plus 5 times
x minus 4.
Good. Catching on, definitely. And now the only way we can combine the tops is if we multiply them. So what's 3x plus 1 times x plus 4, first of all?
3x squared plus 12x plus x, so 13x. 13x plus 4.
Minus, definitely need parentheses around the top. Multiply the two tops together.
3x squared plus or minus 3x plus 5, so 2x plus 2x.
Hold on. 3x times minus 4 is minus 12x.
Oh, yeah, minus
Plus
12x.
5x. That's minus x net. And then what is the number?
And then it's negative 20, or minus 20.
Okay. Now, under each of these, we still have this common denominator, but I'm not going to take up space writing it. Let's simplify what we got. In other words, remove the parentheses and combine all like terms.
So 6x squared plus
Hold on.
20.
Hold on. We got 3x squared minus 3x squared.
Oh, yeah. So then it's just, okay, so then it's 13x so 20x and plus 24.
Okay. Factor that before I go any further.
20.
What can you factor out of that?
2, and then 4. Yeah, 4.
Leaving.
So then it's 4. Okay, 4 times 5x plus 6
Right.
over.
Our common denominator, right?
Yeah.
Now, can I cancel anything? There's what I've got at this point. Does anything cancel?
No.
No, I don't think it does. The 5x plus 6 certainly doesn't cancel with anything. The 4 doesn't cancel with anything. Now you might wonder, if I multiplied everything out, would I find something that canceled? And the answer is always no. It just is. Because if I can't cancel out any of the factors, then there's no point in multiplying that together and multiplying the bottom together, hoping to find something that might cancel. I'm not going to do it. This will be 20x plus 24, and I can't get 20x down here. I can get an x cubed, but that's it. So this got to be the answer. You cannot simplify it further. Okay, one more. Well, actually, it's 8 o'clock, and unfortunately, I have an 8 o'clock, Blake. I'm going to have to leave you. But we got a lot done.
Yeah.
We probably got more done in an hour than I've gotten done with anybody in a long time. Most people I would have gotten through about half of these. So I feel pretty good about your expertise in this. You know this stuff pretty good.
Yeah.
It's all about factoring and finding least common denominators and then finding the proper numerator and combining the numerators, and every single problem is the same way.
Yeah. All right.
I
Thank
will
you.
talk to you next time.
All right. Good luck.
Good night. Have a good night.